Hello, everyone. I hope you're enjoying your first virtual SAFE forum. Hi, I'm Kevin, and I drive the IP and ecosystem for Samsung Foundry. I know that you guys are all probably virtualed out now, but hang in there. I think you'll really enjoy our discussion. I have the pleasure of hosting a panel of industry experts to talk a little bit about one of the hot topics in semiconductor, heterogeneous integration technology. Is this the new norm? Okay, so I've created a simple slide just to set as a foundation for our discussion. Okay, heterogeneous integration technology, this is a new norm. In this most basic understanding, if you look at the diagram, it's just a bunch of different dies, and they could be different process nodes, different functions. And what we're talking about is if you integrate this into a simple single package, and that's what we're talking about, heterogeneous integration at its simplest understanding. Now, this can come in a lot of different forms. Something as simple as two different dies connected together in the package. It can be more complex with some kind of SoC with memory, or something that's I'm calling future integration, where you're putting logic, you're putting memory, you're putting antennas, you're putting a lot of different things all in a single package. And I think there are still challenges in getting to that point, but I think ultimately that's what we're talking about. Okay. So the whole concept of HIT touches on a lot of different topics: disaggregation, chiplets, die-to-die, advanced packaging. All of these are in some ways dependent on each other for this technology to be successful. Okay, especially as we're going to larger dies and higher performance. This all becomes very critical. So I encourage you to sit back and enjoy. To introduce our panel, I would first like to introduce Jan. Jan is the president at Tech Search International. She's been providing market research and tech trend analysis to the industry for decades, and has been in the forefront of this HIT and packaging explosion. She is usually on the other side moderating such panels, so we're honored to have her on the panel this time and getting her perspective and knowledge in this area. Next, we have Tony. Tony brings us the interface and connectivity side to HIT. Tony, who is the CEO of AlphaWave IP, develops multi-standard wireless and wireline IP solutions. As a self-described serial entrepreneur, having background with Snowbush, bSemi, and then Intel, Tony provides us his expertise on the die-to-die interconnect needed in high-performance systems. Don't miss Tony's session on die-to-die interfaces for the next-gen systems and package. He's presenting here at SAFE as well. To complement Tony on the IP side, we have Shankar on the EDA side and tool side. With over 25 years in the industry and having experience from Sierra Design Automation, Mentor, and now Synopsys, Shankar is a senior VP at Synopsys, driving digital implementation with synthesis and place and route, and provides us a look into the tool side of things for this technology. And finally, you can't talk about HIT without having a package expert. Mike is the VP of Advanced Packaging Development and Integration at Amkor. His title alone dictates that he should be on such a panel. Mike also presented a session on HPC packaging trends in heterogeneous and packaging solutions. So if you didn't catch it, I would recommend you checking it out. Clearly, he has a great understanding of HIT. So welcome, panelists, and thank you for joining us. Truly an honor to have you join with us. Okay. So as we start off this discussion, and I want to keep it just really loose and free-flowing, maybe the first question is for Jan, as you're the industry expert, the analyst now, is HIT, is this the new norm? Or are we seeing something that's just a passing trend?
Well, thank you, Kevin. You know, it's a really exciting time in our industry. I mean, surely we can continue scaling, monolithic scaling, but it's very, very expensive to do that. There are examples of where we're going to continue that. But for many, many applications, and in many cases, heterogeneous integration is what we're going to be using moving forward. And that's because to achieve the power, performance, the signal integrity, the power integrity, and sometimes form factor, we need to use heterogeneous integration. And it's not a single package. There are many formats that we could use. We could use a silicon interposer. We could use a fan-out on substrate. We could use a laminate substrate. We could use some kind of 3D stacking. So there are many, many, many different formats that we're going to use to achieve this heterogeneous integration. But I really think it's here to stay.
Okay, you make a good point. So Tony, being on the IP side, what are you seeing with the opportunities for heterogeneous integration and on the IP side and the interface?
Thanks, Kevin. Certainly, the largest semiconductor companies like Intel and AMD today are both using what you show in your diagram as a simple and complex integration. There's a lot of interest. I think the financial motivations, the time to market, incentives, the yield benefits for large SoCs all make sense for a heterogeneous integration. However, I think what's holding it back from being employed by the masses is that it looks simple enough to just take a big chip and to splice it into pieces, but it's not actually that easy to do and get into production. There's a plethora of interfaces being touted for these types of silicon in package parts. It's confusing to the average SoC architect. There's really no large industry standard body driving standards and consistency across all of the suppliers. So what we definitely need is some oversight by a third-party industry body to create a standardized interface that everyone can design to and ensure interoperability with. There's also testing challenges. Testing this many die within a package without direct access points for testers, I think is also yet another challenge that we need to solve and make that solution simple and easy and readily available. So small to mid-size semiconductor manufacturers can all leverage this exciting technology.
Yeah, so Tony, you brought up a good point that it's being used today. A lot of the big companies are using it already. Do you see, as we address these challenges, that it becomes more democratized and small guys can use it as well? You know, Shankar, maybe you can share on the tool side. Are you seeing the tools being able to support this, and that you're seeing more people use it?
Yes, just to pick up from where Jan and Tony left off, I think that we are definitely seeing that for many years in the past, we'll worry about it in the next node. It's something that will come down the road. But now it's here and present, and everyone is looking at HIT in some form or the other in terms of their future roadmaps. I think if you look at it from a tool perspective, one of the reasons why it's not been democratized is that the tool chain is extremely inefficient. It's largely composed off of using PCB tools to do some of this integration, discrete tools for analysis, and there's really no integrated environment which brings together the analysis component, the exploration component, the construction component, all in a single cockpit to accelerate the development of these HITs and also to optimize the performance and power and other metrics. So from a Synopsys perspective, we definitely see a lot of traction for HIT, both at the performance end of the spectrum with high-performance compute, AI hardware, all looking at high-speed networking, all looking at this option to improve system-level performance. And we also see this at the cost end of the spectrum, where with respect to mobile and IoT and those types of applications, HIT is being actively used and being refined as well. So really the opportunity here from a EDA flow perspective is to really develop and deliver this integrated environment, which brings together the exploration, the construction, and the system level analysis all in the same environment, and to really significantly increase the capacity of this environment. Because the tools which have been built off of the previous PCB type of infrastructure, they cap out at a few thousand connections. And modern HITs are going to be tens of thousands of connections. And so you really need to bring IC concepts, IC ideas, IC algorithms into the domain to truly solve this problem in a holistic way.
So Shankar, what you shared is from the tools is so disaggregated. There's still a lot of work to be done to really support the concept from a tools and an EDA side.
That's correct.
How is this impacting you on the packaging side, Mike?
Well, you know, definitely the design tool environment is a big factor. We have spent considerable time working through design flows with customers, usually on test vehicles, so that we can have checkoffs and meaningful handoffs between the two different design communities. Inside Amcor, we're doing quite a bit of module design, but the final system design is still the end customer. So it's got to be seamless. Another thing that I think is, you know, kind of coming up lately is that, you know, as your cartoons show, in the perfect world, you take 10 die and you put them onto one thing and you've got a system, right? And that has a lot of challenges, but testability is certainly one of them. One thing we're seeing, coming back to the test question just for a second, there can be smaller modules combined into larger packages, and those modules can be full functional test at temperature. So that's one way you can establish known good pieces that are coming into the larger system. I just wanted to mention that.
Yeah, I would like to add something to what Mike just said. There is a IEEE working group, it's called 1838, where exactly what Mike said about testing HITs and 3D-ICs is actively being discussed and standards are being defined. So I think it's a very important initiative that the industry needs to get work together to define so that we can solve this problem.
Yeah, okay, that's a good one.
Now, I will offer a glimmer of positivity in terms of all these emerging technologies. I'd say from an IP side, about 50% of the customers we're talking to today are looking at HIT for their next generation product. So that's the amount of momentum that's building up for employing this type of technology for production parts.
So hey, Tony, your last response is a good lead into the next question. This is a simple response for each of you guys, and we'll just go around is, so HIT clearly is a technology that everyone's working on. Where do you think today is the biggest opportunity from where you see things? Jan, why don't we start with you?
Well, I think that in the high performance area, we've certainly seen the adoption. And if you have heard recently, the CEO at IBM indicated that for the AI applications, our current situation is really driving increased adoption of that. And if you'll look at a lot of these AI accelerators and things like that, the packaging that they use is really heterogeneous integration, because in order to put your logic and your memory really close together to reduce the latency. So I think that we're seeing many examples in the high performance space, and certainly other examples as well, but those are the ones that come to mind to me first.
Shankar, your thoughts?
Yeah, I'd agree with Jan. I think high performance compute, networking, I think we pretty much see all the players in that area actively embracing this technology. And further, I would add that that's one of the reasons why a new design environment is needed, because when you look at connecting high bandwidth memory to computing core, like most AI hardware architectures are driving towards, you need to connect tens of thousands of connections, and you need to make sure that the signal integrity on them is correct. You need to make sure that the thermal issues of the design are analyzed and explored while you design the system. And that's where, again, I go back to my point of, if you really have a fragmented tool chain where you explore in one environment, you construct somewhere else, then you use a series of point tools to analyze power integrity, thermal integrity, signal integrity, then it really makes a very inefficient workflow, and that's really hindering the best design from being created. So really the opportunity here is, and this is where Synopsys has introduced a new product called 3D-IC Compiler to really bring all this into an IC data model, build on high capacity IC algorithms to design these types of systems, and really boost the productivity as well as the performance of the resulting system.
Mike, what are your thoughts?
Well, opportunities. If I bring it up to the 60,000 foot level, I think the thing that's kept the semiconductor industry so exciting for so long is you continually get higher performance, and the performance to cost ratio continues to increase. That's why people are continuing to invest, right? So we got to keep that going. Just a simple example is, you've heard it mentioned in the press many times, more and more designs are getting closer and closer to full reticle design. And so there's a transistor limit. And if you can take your transistors from, a really high performing node like 7, 5, or 3, and use those to extract more performance in your cores and pull the IO, a lot of times those high speed IO blocks are fine being in an older node, and free up your precious transistors for higher performance. I think that's serving to maintain that ratio of performance to cost. And I think that is a fundamental that we, have to make sure and derive. And so that means we've also got to come up with ways to combine these blocks heterogeneously that are not a huge cost penalty, so we can preserve that ratio. I think that's pretty fundamental.
And Tony?
So certainly I agree with the other panelists. High performance compute is absolutely a key market that's exploiting this technology. I think there's tremendous opportunity as well in consumer electronics. So one of the last interfaces that has not been integrated is RF technology. You tear down a smartwatch and a phone, you'll find 5 to 10 components all associated with RF connectivity. That's consuming real estate within these consumer electronics. They're typically built in very old nodes, burning higher power. I think HIT is the next wave of integration for this last frontier of connectivity, which is taking the RF connectivity, not just the antennas, but the LNAs, the RF front ends, and bringing them within the package. So that way in the future, when you rip open your iWatch, you'll just find one chip, right? It does your compute, it does all of your connectivity, it'll be super small and help drive down costs and improve that performance to cost ratio as Mike indicated.
Yeah. Well, coming from Foundry, I'd be remiss if I didn't ask the question. What process nodes do you really think that they're targeting today? I'll leave that open for you guys to kind of chime in.
So here, I'll jump in first. Certainly, at least with the customer base that I interface with, it does look like leading edge nodes, large SoCs targeting high performance compute, whether it's data center, whether it's for the compute space, GPUs, AI are all heavily looking into HIT for next generation products. So certainly that does look like the current sweet spot for this.
I think
Yeah,
Mike,
I was concerned with, sorry, go ahead, Jen.
yeah, Mike made a good point. He said, when he talked about you really want to fab your most advanced logic, your transistors on the advanced nodes, and do that and pull the less, go to a less expensive node for the portions of the design that don't require that expensive node to get the cost savings. And we haven't mentioned it, but cost is still very important to many applications. So you have to keep that in mind. And that's, I think, one of the advantages of the heterogeneous integration.
Shankar, you were going to say?
Yeah, I was just going to add to what Tony and Dan just said, which is that, we definitely see this in the high performance compute area, the networking area, and these are all at the most advanced nodes. And what's driving the integration is really the system level performance, right? Some important system level considerations are being optimized, whether it's performance or whether it's memory latency or whether it's the power consumed by the interconnect to the memory. So it's really a design objective that's driving the integration and the choice of this approach in these markets. But then when we look at other forms of integration, whether like the image sensor market, which is really more mature nodes, but still the importance of integration is very critical to that market, or even at the cost end of the spectrum there, it's really driven by being able to bring all these different types of dies together to reduce the cost and mix and match, like the picture here is showing us. So it's really in both performance, cost, and I think you really need an environment that can stretch across this entire spectrum of usage and accelerate this whole direction, because the time is now.
Mm-hmm. Yeah, I was just going to mention, I think, as nodes progress and, those very high performance transistors get delivered in wafer form, those costs are going up steeply for those next nodes. And so the algorithm, the calculus for coming up with performance cost, I think that intensifies for every new node. As you go to 5, is it going to go to 3? And a lot of people are talking about that. So, in one sense, I think that, there are customers out there who have started this already at 7 nanometer, but I think there's going to be a desire and a need to do the homework on calculating that performance cost ratio will even intensify as we go to the next nodes.
Okay. So if I summarize it a little bit, in my understanding, has always been when you're in the semiconductor industry, it's always about driven by cost. But you're saying for this, it's going to be advanced nodes. We're going to be driving toward advanced nodes because of performance. So what are the challenges? Because it was brought up earlier that Tony brought up maybe toward consumer as well, which is very cost sensitive. What are the challenges to reduce this cost and make it more readily available and adopting? Tony, I'll start with you because you were the one that brought up about moving to consumers. And so what is the key challenges to overcome to get this more readily available?
Sounds good. I think Mike's going to play a key part because packaging right now, I think probably drives the largest increase in cost, going from a single integrated die to a heterogeneous package. Likewise, testability. Test times when you're testing these different components. Currently, without an established industry proven flow, everyone is creating their own approach and their own methodology, and that's not allowing test costs to come down as volumes increase, because it's quite a distributed, individualized approach right now. And I think the last piece is making these new interfaces between the die standardized and readily available, and creating a thriving ecosystem. Because right now you have 10 different standards where every company is developing their own heterogeneous interface and marketing it to only interface to itself, right? And that is creating confusion and obviously not letting economies of scale to bring down the interface costs.
So Tony, with that last comment then, do you see the industry merging toward some kind of standardization for this interface? Or for a lot of industries, are we going to have a half a dozen different things that people are all using?
I don't think there'll be one interface for all applications. I think there's a couple different application profiles. One is obviously memory interfaces. The other one is distributed compute, right? So you want to integrate 1,000 CPU cores on a single die, but you can't. So now you need a low bandwidth or high bandwidth, extremely low latency interface to instantiate tiles of CPU cores or AI cores within a package. I think that is potentially a different type of interface. And the third is what we've been talking about, which is the disintegration of IOs, right? You move the big compute onto the next node, you keep the IOs on the N-1 node. And now you might want to mix and match compute chips with different IO chips. And you may even want to get them from different suppliers. So that is definitely ripe for standardization. So that way, different companies, different suppliers can design to a common interface and be assured interoperability when integrated within the package. So I don't think it'll be one for all, but I think it could probably be two, and definitely no more than 3 types of interfaces, depending on the end application within HIT.
Yeah, so Mike, he brought up packaging is out on the forefront for this now. What are the challenges you see going on now and potentially in the next couple of years?
Sure. I mean, if you look at your cartoons here again, you know, there's essentially more and more silicon going into the package, right? And silicon is a wonderful base material. It happens to have a really low coefficient of thermal expansion, as you know. And most of the materials we're using in packaging don't have a really low coefficient of thermal expansion. So every time you make temperature swings, that translates into stress. So I think there is a flurry of research on better materials, lower CTE materials so we can come closer to matching the silicon, and lower temperature materials so that we don't have to go through so many wide temperature extremes and then cooling, which creates a lot of stress in the package. And I think, you know, for the relatively simple ones we're looking at today, the materials today are okay. But I think, you know, this is a call to the material scientists out there. Help us tackle CTE, help us regulate modulus the way we want it, and even help us regulate and lower temperatures for curing of organic materials. I think that's going to be really fundamental as we get larger and larger and larger. You just can't build in a whole bunch of intrinsic stress and have it be well behaved. So today we're okay, but I think, you know, this is going to create a flurry of research for even better materials out there on the packaging side.
Hey, Jan, I know this is an easy question for you because you've been looking at this market so long. What do you see as the major challenge now?
Well, I think we have to have greater cooperation and partnerships, kind of like building on what Mike said, even with the material suppliers. But, you know, 30 years ago, when I first got into this segment of the industry, we, you know, silicon design people really didn't talk to the packaging people that much. You know, packaging was an afterthought. And now we really have to do co-design, and it's not just a buzzword, it's a real event. And I think that we have to have cooperation across the ecosystem in order to achieve the full potential of heterogeneous integration. And that even includes, like Mike said, the material suppliers and working with them as well. A lot of partnerships.
And Shankar, you already mentioned some of the challenges in the tool side. Anything else you'd like to add to that?
Yeah, I'd like to just pick up on Jan's comment that this is truly a multidisciplinary area, and therefore partnerships, collaborations, alliances are going to be critical to bring the best solution for design teams that are trying to go in this direction. And you know, you asked what is holding us back. I mean, I would really start with a design environment to design these systems efficiently, right? We talked about very fragmented workflows, very low capacity, aging infrastructures trying to deal with tens of thousands of connections. The fact that the analysis tools are completely disconnected from the construction tools. And then, you know, as Mike mentioned earlier, there's a flurry of research and different types of materials being used as the medium to connect these dies, and that those impose and trigger a whole bunch of new requirements. So in many ways, the kind of rapid EDA innovation that has resulted in these node transitions happening so aggressively to augment the work that's been done by the IC foundries, I think we need the same pace of innovation and enablement to enable really the full potential of HIT. And I know we are working closely with you, Kevin, and Samsung Foundry to enable this, and that in conjunction with a whole ecosystem of partnerships on the IP side, the packaging side, as well as companies that provide the design tools to accelerate the development of these systems. I believe that's what's going to be essential.
And let me jump in a sec. You know, when I think about what Shankar said, it reminds me of earlier in my career, graphics chips became so large that EDA tools didn't have the capacity to build the next generation chip. And what happened was the EDA tools evolved and allowed chips to be built as tiles and come together as tiles, right? And really, I think what's happening with HIT is a similar type of evolution where in order to scale further, we need the tools that now enable tiles not only within the same semiconductor, but across different pieces of semiconductor within a HIT package.
Yeah, that's going to be tough. So I'm going to ask one kind of tough question to kind of end things off with. Look into your crystal ball for your particular market, whether it's EDA, IP, packaging. What does this look like in 5 years? So Shankar, let's start with you on the EDA side. In 5 years, what do you see have changed in the EDA side to support this technology? And the others can think about their respective segments as well.
Yeah, I think on the EDA side, I mean, we see this really percolating from high performance compute and AI and networking to a much broader segment of customers across pretty much all nodes, trying to benefit from both the scaling as well as benefiting from the advantages that HIT offers from a system level integration perspective. In many ways, I mean, looking in the crystal ball, I just see a huge opportunity here to really bring many of the concepts that enable the IC design flow to scale to handle the biggest chips in the industry today, like hierarchical concepts, multiple levels of hierarchy concepts, the ability to route millions of connections efficiently, the ability to analyze billions of gates efficiently. I see many of those concepts really percolating into this domain and really enabling far more powerful systems than what this picture shows. Because there's no reason that die 1 in this picture is not a HIT in itself, and die 2 is not an HIT in itself. So, I think that the true long-term direction is to bring all the concepts that have benefited the IC world into the HIT world, and then deliver this very scalable system that combines all these different types of analysis together in one cockpit.
Okay. Tony, 5 years from now, what's IP going to look like for HIT?
So right now, the industry views IP as a database that can be instantiated within an SoC. And so from a connectivity perspective, large SoC providers currently just want a GDS they can drop in and their interface is done and taken care of. The reality is when you have numerous components being integrated within a package, I don't think any one company can design all the components themselves. So I think you're going to see the definition of IP expand. It could be a GDS, it could be a larger subsystem GDS, or it could be even one of these little chiplets that provide the I/O connectivity that gets dropped in and ultimately manufactured. So I think HIT is going to expand what an IP supplier is to help provide the solutions for SoCs and HITs 5 years from now.
Sounds like there's going to be a lot more pressure on the IP guys.
Looking forward to it, Kevin.
Mike, 5 years, what are we going to see in packaging?
5 years, okay. That's a long time in the semiconductor industry, right?
Exactly. What's your crystal ball tell you?
Well, I think the first phase is well underway. We've got HBM in 2.5D kinds of integrations. That was a great breaking ground for creating some of the packaging technologies that we're going to need for the next few waves. But I think testability and I think power distribution, actually spatial power distribution in the future, out in that 3-5 year time frame is going to become ever more important. So I think we're going to see a lot of package level integration. It's going to be heterogeneous. I also think there's going to be smart modules, meaning there's going to be smart ways to bundle pieces together in a module form that is still testable. And with the EDA tools becoming what they are, that's going to be thermally aware everywhere. And so, the package is going to be the XY locator of power sources in a smart way, thanks to the EDA tools, so that we bring all the silicon together and we can still dissipate all the power. And sort of, the last edge on that theme is we're going to have to continue to develop really awesome power dissipation solutions, because we are putting more power, more devices, and more power density in one place. So I think, we're in the first phase now. We're getting things put together and learning a lot on how to do it. As we expand that into, the ultimate system 5 years from now, I think it'll be pieces of other modules integrated together in smart ways, so that the total system performance to dollar ratio is just stellar. It's just going to blow people's imagination away.
And Jan, finally to you, you have the big picture. So tell me, what's going to happen in this industry 5 years from now?
Well, we've seen a lot of 2D type configurations, planar side by side, but I think in the next 3 to 5 years, we're going to see a lot more of this kind of chiplet strategy and a lot more 3D integration. And I mean true integration. And I think that is going to give us some advantages. It's also going to give us challenges. But again, with these partnerships, I think we can work through those challenges and, bring forth this really ultimate goal of a 3D configuration for heterogeneous integration.
Okay. So, what I got from just hearing you guys talk is this is clearly something that's going to become a norm moving forward, but we still have a lot of challenges to cover. Probably one of the biggest ones that I'm picking up from you guys is not just a packaging problem or a tools problem or an IP problem, is we can't do it in a silo like we've done in the past.
Right. We're
going to have to work together. We're going to have to kind of build an ecosystem to really drive this if we're going to be successful in this heterogeneous integration. A combination of all of us working together. It can't be just one packaging working on its own or IP or tools working on its own. Okay. So absolutely. I thank you for your time. I wanted to give each of you guys, a quick 30 seconds or minute to make final comments that you'd like to do. So why don't we start with you, Mike? Just to close the session off, is there anything you'd like to leave our audience with?
I guess I would like to leave the idea that our company is investing in this. It's not just an idea, it's becoming real. We have real customer designs coming to us. I think we have to work together. So these opportunities to collaborate and share ideas are going to be even more important than they ever were before. And, the proper investments over time, I think we can fully realize what heterogeneous means. And, Amcor's really looking forward to helping to enable that to be reality.
Okay. Shankar, we'll move to you.
Yeah, firstly, thank you for inviting me to the panel, Kevin, and also thank you to all the other participants for your excellent remarks today. What I'd like to say is that really, HIT is here, and it's going to become pervasive in the next 5 to 10 years across a broad range of designs. We really need a new series of partnerships across the industry to enable it. We need new tooling to enable it. And I think we also need to really build this ecosystem around HIT. And we are very happy to be working with Samsung Foundry and many of the other partners in the space to enable that. So thank you.
Tony, your parting thoughts?
It's been my life's mission to make high performance, high bandwidth interfaces as simple and easy to integrate as possible. It's my personal goal to work with partners in the industry, such as our panelists here, and with Samsung Foundry to deliver an efficient portfolio of die-to-die interfaces that make it very easy and low cost and low power for next generation SoCs to integrate to help accelerate HIT technology moving forward.
Thanks, Tony. Jan, we started with you, and I'm going to let you end with you and your parting thoughts.
Thank you. Well, I think heterogeneous integration is going to be an exciting topic to continue to cover, and we need to continue these discussions like this forum. And I really appreciate being invited to it. We're going to continue to monitor this, and I think that we need to have more discussions about, what are the challenges, how do we need to solve the problems that we encounter, and, participation in this and other avenues like the Heterogeneous Integration Technology Roadmap. So I hope to continue these discussions, and thank you very much.
Well, guys, thank you very much for your time. It's been a pleasure talking with you guys. As my role in Samsung Foundry is to drive ecosystem, and I agree with all of you guys. It's really important for these partnerships to build up this infrastructure, to build up these partnerships and work together. So thank you very much for your time, and I hope the audience got a lot out of what you had to share with us. Thank you.
Thank you, Kevin.
Thanks, Kevin. Thanks, everybody.